We will now derive the midpoint theorem, which reveals a powerful geometric rule about triangles. You will learn how the connections between midpoints relate to the third side using only simple constructions. We will use parallel lines and congruent shapes to build our proof step by step. First, consider triangle ABC. Let D be the midpoint of side AB and E be the midpoint of side AC. We want to prove that the segment DE is parallel to the base BC and that DE is half the length of BC. To begin the proof, draw a construction line from point C that is parallel to the side AB. Next, extend the segment DE until it intersects our new construction line at a point F. Now we compare triangle ADE and triangle CFE. These triangles share specific angles and side lengths. The angle at E in both triangles are vertical angles, meaning angle AED equals angle CEF. Because AB is parallel to CF, the alternate interior angles, angle DAE and angle FCE, are equal. Since E is the midpoint of AC, we know side AE must equal side CE. By the angle-side angle rule, triangle ADE is congruent to triangle CFE. Congruence tells us that their corresponding sides are equal. So side AD equals side CF. And DE equals EF. Remember that D is the midpoint of AB, so AD equals DB. This means DB must also equal CF. We now look at the quadrilateral DBCF. We know side DB is parallel to side CF by our construction. Since DB is parallel to CF and DB equals CF, the quadrilateral DBCF must be a parallelogram. A key property of parallelograms is that opposite sides must be parallel. Therefore, DF is parallel to BC. Since DE is part of the line DF, we have successfully proven the first part. DE is parallel to BC. Now for the length proof. Since DBCF is a parallelogram, its opposite sides must have equal length. This means the length of DF is equal to the length of BC. Earlier, we established that DE equals EF. This means that DF is composed of two segments of length DE. Replacing DF with 2 times DE shows that 2 times DE equals BC. This immediately shows that the length DE is exactly 1/2 the length of BC. Consider a triangle base BC measuring 20 units. Based on this theorem, the midpoint segment DE must be exactly 10 units long. We proved the midpoint theorem by showing that the construction creates congruent triangles and a full parallelogram. This confirmed both required properties. The midpoint segment is parallel to the base and is half its length. Understanding these geometric constructions helps us see how simple rules create powerful relationships in shapes. Generate your own educational videos for free at eduvids.vercel.app.